Today we're going to be going through a very simplistic explanation of how a water maker works. We'll be using the schematic here as a reference. Most water makers used on boats, yachts, RVs, and in off-grid applications make water from a process called reverse osmosis. We're not going to get into the theory behind reverse osmosis, but instead we are going to simply review the flow sequence and the components that function to make the water. For our purposes, we'll consider the reverse osmosis technology to simply be a very, very fine filter that takes pressure to push fluid through it. We'll go through the entire process step by step, but simplistically, you bring seawater into the vessel, using a pump, push that water through pre-filters. From the pre-filters to a high-pressure pump, the high-pressure pump pushes the filtered seawater through RO membranes. The RO membrane technology allows only pure water to pass through, rejecting 99% of contaminants. Pure water is then sent to the vessel's freshwater tank. Brine water is dumped overboard. And when the water making cycle is complete, we must flush the membranes with clean water to reduce bacteria buildup. The second slide shows us the basics of raw water entry into the water making system. The through hull is where raw seawater is brought into the vessel. The seacock or ball valve and strainer come next. The ball valve can be turned off in the event of a problem, and the strainer is there to stop major contaminants such as seaweed, small critters, and other debris from reaching the water maker components. The seawater pump will draw water from the strainer and push it through the filters, in this case a 20 micron and a 5 micron filter arrangement, before the raw water goes to the high pressure pump. Most systems will install a pressure gauge after the filtration setup, so the owner can monitor the condition of the filters. Typical pressures here will be 15 to 60 pounds before the high pressure pump starts. After the high pressure pump starts, the pressure can go very low depending upon the strength of that pump. The third slide adds the high pressure pump and the RO membrane setup. The high pressure pump pushes water through the membrane housing at significant pressure. Once adjusted, this pressure can be over 800 psi. The slide shows a system with one membrane. It is the membrane size and the high pressure pump that determine system output. Typical 40 by 2.5 inch membranes are advertised to produce up to 700 gallons per day if everything is perfect. More realistically, that same membrane will produce about 520 gallons a day. The lower number takes into account time to flush the system every so often. We recommend flushing the membranes every 4 hours if you're continually making water. The fourth slide adds several components that the user must monitor to ensure safe operation. The pressure gauge shows the pressure on the high side of the membrane circuit. Just after the pressure gauge is the needle valve, which is used to set the high pressure. The check valve is there to ensure seawater does not come back into the system. Once the system is running and appropriate valves are open, the user must slowly turn the needle valve in the closed direction while watching the pressure gauge. Turning the needle valve too quickly can damage the membrane. As the needle valve begins to close to its seat, the pressure will begin to increase quickly. Stop closing the needle valve when the pressure reaches about 750 psi. Although the operating pressure is typically 800 psi, some systems will have pressure momentum, which is when the pressure continues to climb even after the user has stopped closing the needle valve. Allow the system to settle out, then continue to close the needle valve until it reaches 800 psi. The difference in output between 700 psi and 800 psi is only 4 gallons an hour, so there is no need to push the pressure higher. This last slide shows the low pressure side of the membrane circuit. This is the drinking water side. Here you will find a flow meter which shows water production in gallons per minute or gallons per hour, sometimes liters per hour. Just after the flow meter, there should be a TDS meter. The TDS meter measures total dissolved solids, which is an indication of water quality. It displays that measurement as ppm or parts per million. Do not consume water with a TDS reading higher than 500 parts per million. Most RO systems will produce water with very low TDS readings, usually less than 200 ppm. Many cities are producing drinking water at ppm levels above 350, so your RO system is making water that is cleaner than most cities. After the TDS meter, there should be a valve to allow the user to isolate the system from the fresh water system on the vessel. The user will open this valve as they prepare to make water and then close it upon completion of the water making cycle. If this valve is not opened during operation, excessive pressure will build up in that line and could break that line or tubing. So let's review the system. We bring water into the water maker through a through hole. It then goes through a strainer before arriving at the seawater pump. The seawater pump pushes the water through pre-filters and then onto the high pressure pump. The high pressure pump then pushes the raw water into the membrane at pressures upwards of 800 psi. The membrane has two sides, a high pressure side and a low pressure side. The high pressure side is controlled by the high pressure pump and the setting of the needle valve. Remember, increase the pressure with that needle valve very slowly so as to avoid membrane damage. The low pressure side receives the water that has been filtered by the membrane and feeds it through the flow meter and TDS meter and then onto the freshwater system on the vessel.